Welcome to my YouTube channel Kadam Academy. Dear friends, this is the new chapter we are going to start with the balancing. Balancing chapter, you can visualize the balancing of this tire and balancing of the work and life. That is also important, friends. This is my message to you. If you are not subscribed my channel, please subscribe for the more and more videos on the balancing. Friends, what are the contents of the balancing you are going to study while you are in engineering? So these are the contents: static and dynamic balancing, balancing of rotating masses in single and several planes. You can visualize through these engines, this primary and secondary balancing reciprocating masses, balancing in the single cylinder engines or the multi-cylinder engines, or you can visualize in inline vertical engines, V-type engines. You can visualize here W-type engine, radial engine, opposite cylinder engine, horizontal engines, and these are single cylinder engines and double cylinder engines. This balancing in the various engines, multi-cylinder, inline engines, and the V engines, radial engines and V engines. These radial engines, V engines, and the inline engines are single and the double or multiple cylinder engines. We have to study the balancing of these under this unit. So friends, subscribe my channel for the more and more videos. So we're going to start with the what are the outcomes after watching this video. What do you learn? All the videos related to balancing you are going to learn. You are able to apply the balancing technique for a static and dynamic balancing of multi-cylinder inline and radial engine. Then we will be studying about dynamic balancing. So that we will study, or you are going to able to apply the techniques. Know the balancing of wheel or rotor on computerized balancing machine. You are going to see the video on these type of the balancing machine live recording. Okay, so friends, for this was the more videos to describe experimental verification of dynamic balancing. There is a experiment conducted on the dynamic balancing in the laboratory of the JSPM JSUE lab, dynamics of machinery lab. So watch that video in a practical videos of the playlist. Okay, thank you. So next is what? High-speed engines. What are those engines? In the rotation of the machines and the systems, what will happen in high-speed engines when they are working systems are growing, and this is the present scenario. It is a requirement of this type of engine or machines are required and which are run at a very high speed. This is the present day scenario. But what will happen if the moving parts are there in rotary motion or the reciprocating motions? The machines are not in complete balance. If the machines are not balanced and due to the inertia forces are set up, and which will produce what? Dynamic forces in the machines. These are having rotating, revolving or reciprocating parts are there, which will create the dynamic forces. If we eliminate such imbalance of the system to ensure the smooth and trouble-free smooth operation, which will increasing bearing life, the structure life, that machinery life, and better efficiency, results in a better efficiency. Bearing loads. What will happen about these bearing loads? Increase in the bearing loads, that will destruct the or life will be decreased. And stresses and in the members will increase due to the dynamic forces. Okay, or there will be possibility of such vibrations may create and may produce the excessive noise or cause wear and tear of machine parts and results in the faulty performance of the work for which machines are designed. So for this purpose, we have to eliminate the unbalanced forces. For this purpose, we have to study this balancing chapter. Balancing is very necessary, especially in high-speed applications. The applications such as electric motor, okay, generators. See here, the steam is due to the steam is produced which will high speed which will generate the power. Here electricity generated through the steam power. Okay, and this is the flue gases which will go outside. This is the boiler which will burn the fuel. Here coal is burning that fuel, and it will create the this is the boiler. Boiler tubes to boiler. Okay, which will create the steam, superheated steam, and that will create the rotation motion. The energy converted, this energy is converted into this rotational energy, electricity energy. Okay, so this type of the generators are there, or turbines. Here is the turbine is there. Okay, that will create the electricity. Or pumps, you can visualize through these pumps. Here the pump is connected to this motor, and this pump will lift the water or the liquid or the whatever you are want to lift through the various types of pumps. They are also having a high speed. This is the requirement of the industry. So there is a high speed. So it will create the, or in the machine tools, high speed machine tools are there, and where to create the jobs by using the machine tools. Okay, in that also rotation motions are there, and there is possibility of the creation of the that will reduce the quality of the job. For this purpose, we have to avoid this unbalanced forces. So balancing is necessary. Again, few examples we will study: aircrafts, paper mill. In paper mill also there is a rotary motions are there. Okay, in blowers. Okay, blower also we have to balance that blower. Inside this blower is there, that will we have to balance. In textile machines also there is a balancing is necessary. So in sugar industries, like this fabrizer, which will cut the sugar cane in very small pieces, that is also required the balancing. Now there are various domestic application it is required. But what are the reasons of unbalance? Loss of mass from the rotor system. Thermal bow caused by rubbing between the stationary and rotating components of rotor system. Shape of rotor unsymmetrical. The shape of rotor is unsymmetrical. It will also, and this unsymmetrical exists due to the machine error. Okay, the material is not uniform, especially casting. During the casting, the material is not uniform. That will also create the. It is not visible to us inside the material body. It is there. Deformation exists due to the distortion or manufacturing, or the tolerances are there. During the manufacturing, the fabrication problems, there is a casting or eccentric machining and poor assembly will be cause the unbalance. Distortion problem, that is the rotational stresses and aerodynamic and the temperature changes, that will also create the unbalance. So these are the reasons, various reasons are there other than this one. Okay, why balancing is so important? Why balancing is so important? Level of unbalance that is acceptable at a low speed. Okay, at low speed it is acceptable, but unacceptable at a higher speed. Higher speed way, it's very dangerous. It's not acceptable. As machine get bigger and go faster, the effect of the unbalance is much more severe. Force caused by unbalance increase square of the speed, and if the speed is double, the 4 quadruples. If the speed is triple, force is increased by 9 times. Okay. So friends, balancing classification we are going to study now. But before that, what is balancing? Balancing is the technique of correcting or eliminating unwanted inertia forces and movements in a rotating machineries. Okay. Friends, what will happen here? The classification, I will show you the classification of balancing. Here, the 3 types of the machines, the balancing are classified here. How? The rotating masses, reciprocating masses, and the combine of rotating and the reciprocating masses. Okay. In the first, rotating masses is single plane or the multiple plane, different planes. These are the 2 types under the rotating masses. Okay, this is a single plane, or if there is a multiple plane, that will the rotating masses. Conditions, 2 conditions about the 2 types of the case for the rotating masses. Similarly, in reciprocating, you can visualize this IC engine. So here reciprocating. Here primary force and couple, secondary force and couple. These two types of the reciprocating masses we are to study. We are going to study these two. And this combination of this rotating plus reciprocating, that is the third type, combined rotating and reciprocating masses. This is the classification of the balancing we are going to study in coming videos. Friend, what is the balancing? Already we have studied. It's a technique of correcting or eliminating unwanted inertia forces and movements in a rotating machineries. Friend, the objective of balancing an engine are to be ensure that the center of gravity, that is center of mass of the system, remains stationary during the complete revolution of the crankshaft or inside the crankshaft or in the rotary masses of the rotary systems. That couples involved in the acceleration of the different moving parts that must be balanced each other. If both the conditions are satisfied, then it is completely balanced. Okay, there is a no unbalance or there is a no unbalance. Okay, friends, centrifugal force. What is the centrifugal force? A particle which is moving in a circular path experiences a centripetal acceleration toward the center, and this force is required to produce it. Two forces required to produce it, but an equal and opposite amount. Here, see, this equal and this mass is there at a distance r. It is rotating with the omega. Okay, at a speed, rotational speed. That equal and opposite force acting radially outwards. It is radially outwards. See, this is the disk at the eccentric. This mass, center of mass is there, which is moving outside. This force is me omega square. M is the mass of this disk, E is the centric distance, and omega square is the angular velocity. Okay. Similarly here, m r omega square. R is the distance, E is the eccentric center of mass. Okay. Distance of eccentricity, center of mass from the center of axis. Okay. The axis distance is r here. Is m r omega square. This is the centrifugal force. This force is equal and opposite to the centripetal acceleration and acting towards the radially outward side. This is the radially, this is the axis, and this is the axis, and radially outward side acts on the axis of rotation and is known as centrifugal force. So this is the concept of the centrifugal force. We just want to clear you. This is already studied in 11th, 12th, first year also. Balancing of rotating masses. What is that? Center of mass, that is CG, of rotating component of a machine such as the flywheel or rotor or alternator that does not lie on the axis of rotation. If this center of mass is not axis of rotation, then there is a centrifugal force which is given by this value. The Fc is equal to mr omega square, and is in Newton. And also we can write this force in mv square by 2 also. Where the Fc is what? Dynamic or centrifugal force in this balancing of rotating masses. This main force is there, the centrifugal force. Okay. The dynamic or centrifugal force in Newton. How to find out this m or omega square? M is the mass of rotating mass in kg. Omega is the angular velocity in radian per second. Eccentricity is r or this E. Eccentricity means this center of here. This is the center Eg, which is at the distance E or R from this center of axis. Okay. The axis line is there. And this V is the mv square by 2. Here V is the linear velocity in meter per second. And the two types of balancings are there, the static balancing and dynamic balancing. First we'll study the static balancing. Under the static balancing, the balance of forces due to the action of gravity, that means the center of mass, here center of mass. Okay, this shaft axis is there. This is the disc, the shaft axis of the shaft, and this center of mass and this axis of the inertia. Okay, the body is said to be a static balance when its center of mass is in the axis of rotation. That is on this axis of rotation. So what will happen if the axis of rotation is not there, or it's not on the axis of rotation? So that will its axis must be matched with this shaft of axis. not match, so what will happen? This vibratory behavior, it will start. In the system in rotation, dynamic forces may produce the vibrations like this. So what is the actual conclusion in this static balancing? All the dynamic forces, summation of the all the forces must be equal to 0. Then it will balance. Means here is the extra center of mass is more, then that is not matched with the axis. So we have to put here another weight at some distance. We have to calculate and what distance we have to maintain, and so that the axis of shaft axis that will match the principal axis of inertia due to the addition of the extra weight on the other side of that. So it will be balanced. That unbalanced system becomes balanced. So the summation of F means that all the centrifugal forces summation become equal to 0. Then in that case, that is the balance. In dynamic balancing, second type of the balancing is what? Dynamic balancing. Here the center of mass, that is CG, here we can visualize of the system must be lie on the axis of rotation, like in static balancing. Then it may statistically balance. This is the first condition for the dynamic balancing. The second condition is important. Here, what will happen? Due to these forces, the resultant couple due to all dynamic centrifugal forces, and due to this action, inertia forces acting on the system. Why these centrifugal forces occur? Due to the inertia forces, and it will create a couple, resultant couple. And if these couples are created, are the summation of all the resultant couple due to the dynamic or the centrifugal forces is equal to 0, then it is both the condition will satisfy the statistical balance and the dynamically balance. So hence the dynamic balancing is there. If not balanced, then what will happen? This is like a behavior, like this vibratory behavior, it will occur, and that will harmful to the body, all the bearings, all the system, and noise will be created and life will be decreased. So friends, what are the 3 outcomes of this video? And you always learn by self-assessment only. Thank you very much for watching my video. If you are not subscribed my channel, please subscribe it. Thank you very much. Kadam Academy.